Hi, grade 12 students. This is your part 2 of my functions exam writing tips. We're on topic number 6, exponential functions. Know the meaning of the a and b values. So this is on your formula sheet or your reference sheet. Let's just take a moment and look closely at the exponential section. So let's put a big highlighter around the exponential section. Now, we have some information here that the a is the y-intercept, and the b tells us increasing or decreasing. But it also says here in the center of our reference sheet that the y-intercept is the initial or starting value. So not only do we know it's the y-intercept, we know it's the initial or starting value of whatever the topic is in our word problem. And the b for an increasing has to be greater than 1, and this is an example of that, 1.08, which is actually an increase of 8%. And the b in the decreasing function needs to be less than 1, and we have an example of 0.95, and that's actually a decrease of 5%. Whenever you're lowering a number by a percent, you have to subtract it from 100. So think of it as, if I'm taking 5% off, I'm leaving 95% behind. Okay, I'm taking 10% off, I'm leaving 90% behind. And a big clue, and I'm not sure if you'll get a question like this, but maybe you will, is you can solve these functions from a word problem, and that's what we're going to look at right now. The future deer population in Provincial Park is described by the function p equals 365 times 0.98 raised to the power of t. So if you're grabbing your pens and annotating, you should be noticing that we have a decreasing function. We're decreasing actually by 2%, decreasing by 2%. Now it goes on to say t is the number of years from now and p is the population. What is the present size of the deer population? Well, there are 365 deer in the initial population. Or you could say the starting population. Okay? How can you tell that the deer population is decreasing? We know that from our reference sheet. The b value is less than 1. That would be a good answer for 1 mark. I threw this in here again, solving for an x or y. That was tip number 3, and adjusting the window settings in Desmos. I'm going to go ahead and put this equation into Desmos, and then we'll come back and we'll solve this. All right, I've typed in my equation exactly as I've seen it on my exam question, and lo and behold, I don't see anything on Desmos. That's because we really do need to be able to adjust our window settings. I'm going to just make Desmos my entire screen, and I still don't see anything. So we could reset it to the home center where we're centered right around the 0. We don't see anything. You can scroll out with your mouse, and then you start to see some information. And you can see some key pieces of information, like where it crosses the y-axis, and you can see it approaching the x-axis. And at this point, it might be a nice idea to see just the top right-hand portion of the screen. So you have to decide where you're going to do your cutoffs in your window settings. So I'm going to make my x-axis go only just slightly negative, maybe negative 10. And you know what? It's pretty good right now, actually. I like the way my window setting looks, and that was the only adjustment I really needed to make. Now, going back to my question, what value did they give me? Part C. The park ranger will implement a conservation plan if the deer population decreases below 100. Could this happen in the next 20 years? Well, they gave us two numbers. So this one's a little, one you want to really take your time with. So they gave us a population of 100, and they gave us a time of 20 years. So I feel like we could probably answer this question in a couple of ways. P equals 100 and T equals 20 years. Let's take the P equals 100 first. That is a Y value, and so we would write it in as Y equals 100. And let's click on where that happens. Okay, so if we're starting at with an initial population of 365 deer. The deer population is decreasing, but it's going to take 64 years before the population goes below 100. So we've used the function to support our answer. If we had done it the other way, and we put in x equals 20, we can see here that at 20 years, yes, the deer population has decreased. It's gone from 365 down to 243, but 243 is not below 100. So we have got some information that supports our answer, and our answer will be no, this likely won't happen in the next 20 years. And you could say that, you found out that it would take 64 years for the deer population to reach that level, or you could say that when we looked at the estimate for 20 years, it was well above at 243. So there's a couple of ways you could answer that question, and that is a good practice question to look at. Tip number 7 is that when we're looking at sinusoidal functions, we really need to know the meaning of the A and D values and the term period. So let's take a look at our reference sheet and see if our reference sheet tells us any of this information. It's something that we have gone through a lot in class, but it's always good to have it handy on a reference sheet. Here's our reference sheet. Here's the section on sinusoidal functions. A is the amplitude of the function. And if you forget what the amplitude is, hopefully this little description showing there's the A, and here's amplitude is a distance. Amplitude is the distance that the sine function goes when it travels from the midline to the maximum, and then again from the midline to the minimum. So we have this section here is also the amplitude. And we have the amplitude repeating itself over and over and over again as it goes from the mid up. This amplitude is going from 1 to 4, so we have amplitude of 3. And that example is there to help you, but you're going to have different numbers, just like the question that we're going to look at has different numbers. So these numbers are only here as a guide. The amplitude is not always going to be 3. And that is the first number in your sine function. So if we were to do this question as a regression, we should be getting 3 as the first number in our function. And D is the midline. So D is the line that is found in the center of the sinusoidal curve. The sine function always comes back to the midline and then goes down and then back to the midline and up. and D is the number on the end. And so whatever the location of the midline is, sometimes they call it the median, so that's why we say the midline or the median, but those mean the same thing. That value is on the end of your function, and in this example the midline is 1, and this example is here to help you piece together the information on whatever question you might get. And when we look at our functions that we're going to see, if we were asked a multiple choice question with this one, we would want our last number on the function to be a 1. So we're going to go back to our question and see if we can figure it out. So here we are. We can tell we're going to have a midline on our function. Our function's also going to have an amplitude. And whatever numbers we decide they should be, hopefully we can narrow it down and pick the right option. So let's start with the midline. They give us a few options. Is our midline 5.5, negative 5.5, 5.5, or negative 5.5? Well, what do you think would be in between negative 3 and negative 8? Probably not a positive 5.5. So we're going to go with the option of negative 5.5. That's actually what it is. If we added these two negative numbers together and divided by 2 to find the midway point or the average of those two numbers, we would get negative 5.5. So good tip in a multiple choice question is if you can't cross off an option, cross off your options. If you remember the show Who Wants to Be a Millionaire, we now have a 50-50 chance of getting this question right. So if the midline is negative 5.5, how much did our function go up to negative 3? Did it go up by 2.5? Is negative 5.5 plus 2.5 3? I'm slow with my pen, but just stick with me. Is that the correct answer? Or is it negative 5.5 plus 5 equals 3? It would not be this one. You can check this with your calculator, but we can see the distance that this travels up is 2.5, and the distance that this travels down is 2.5, so the amplitude is 2.5, and the correct answer is B. It's really pretty easy to do if you know the meaning of A and D. I've also got on here that a good tip would be to know how to find the period. Period just doesn't apply to this question, but the period is the distance from two identical points. So I like to pick, 2 max or 2 min. And if you were doing this on Desmos, I would recommend that you put in a nice line here. So a line that says y equals negative 3, and you have Desmos identify those 2 points for you. Okay, and then you subtract the distances. The x values will be different, and those x values will be subtracted, but the y values will be the same. So you'll know which 2 numbers to subtract. It'll be the 2 numbers that are different, and that's how you can find the period. Tip number 8, know the 4 things to have on a graph sketch. You need to have a consistent axis numbering, reasonable domain and range, axis labels, and consistent shape. So we have a question like this where they gave us a big spot to draw a sketch, a clearly labeled sketch of the equation. So on my next page, I'm going to show you some examples of where people might have lost marks. So the 4 things we need to have, I might be going out of order, but we need to have axis labels. This person lost a half a mark because they didn't have both axis labels. They had one but not the other one. This person nearly got it. They had time in seconds, but they forgot to say height of the ball in meters. But one of the things that they did do really well is they went and had consistent numbering. They went 1, 2, 3, 4, 5. You can see they're going by ones. And they're also consistent here, 0.5, 1, 1.5, 2. You don't have to have the same system of numbering on each of the axes, but you have to be consistent. This person also did a good job of consistent numbering. They didn't change their method of numbering as they went along. And here they went by 0.2s, and they were consistently going by 0.2s. Just too bad about that half mark deduction there. Here's a real problem. We've got someone starting out by going 0.5, 1, 2, 3. So this person didn't decide whether they were going to go up by 0.5 or whether they were going to go up by whole numbers. It doesn't matter which one you do, you just have to be consistent. And it does kind of matter how you draw your graph because you do need to be able to space out the numbers and fit things on properly. So they lost a mark here. They also didn't put any axis labels, like none at all. And the axis titles are always given to you in the question. I'll show you where. I'll just go back to the question. Here it is. If you to just, I know you haven't done your exam yet, but if you just copy exactly those two things and put them on your axis, you're good to go. You've got time in seconds, height of the ball above the ground in meters. So not having consistent labeling is a bit of a problem here. The basic shape, these two graphs were done quite well, but if the vertex was, let's say, drawn, they didn't put much attention to where they're putting the vertex and they went past the point where it should be, that's losing some marks for not getting the basic shape. And finally, I actually decided to take this person's response here and copy it and say, one of the things you might have noticed is they didn't actually sketch their graph. They only put just dots. The only thing they would have needed to change was adding the graph and putting the unit. And another thing that I see that didn't happen, which sometimes happens, is sometimes people will extend this line further, but that can't happen because that would mean that the ball has negative height and the ball isn't going to go into the ground. Also, we can't extend this line here because we can't have negative time. So had those two lines been extended, that would also have been an error. So there are 4 things to think about when you're doing a hand-drawn sketch, and it might be a good idea just to go look at your sketch, make sure you've got all 4 items taken care of. And finally, thanks for hanging in there. We're getting to tip number 10. And that's something we practiced a lot in class. I made you guys go around to the whiteboards and practice, making a table of values for a sinusoidal function. So here is our question. We have the London Eye is a giant Ferris wheel in London, England. It has a maximum height of 134 meters and a minimum height of 0 meters. So we are starting to get some y-axis information. We know that our y-axis is going to go from 0 to 135. We also kind of know what our median is if we find the middle of those two numbers. And I'm going to start reading here, and 1 complete rotation, and 1 complete rotation takes 30 minutes. So this Ferris wheel is going to go up and around and back to the starting point in 30 minutes. the passengers get on at the bottom of the ride. So passengers getting on, I'm going to change my color. And passengers getting on, then moving up, then moving up. Now the passengers at the top, they're starting to come back down, and they're back where they started. And this full rotation takes 30 minutes. So we can't just put 30 minutes wherever we want. We have to make sure we're back to our starting point for our 30 minutes. So now we can say the middle is 15 minutes, half of 15 is 7.5, and half, another 7.5 added to 15 is 22.5. That's one way of doing it. You can also, if you really want to see it look like a sine curve, you can start sketching it. Now, we didn't have to sketch this in order to make a table of values, but I think it helps, right? I hope you think it helps. What is the center of 0 and 135? That will be very important to get, so I'm going to get my calculator out. So I want to make sure I'm getting it right. 135, you know, you could say, I'm going to do 135 plus 0. I know you know that that's 135, but what we're going to do is we could add these two numbers and divide by 2. Okay, I did more work than I had to, I know I did, but maybe you'll have a question where that'll come in handy. 67.5. All right, now let's make a table of values and just look at each little point. Where on the X are we? And we just need to do one complete rotation. So when we're at 0 on the X, we're 0 on the Y. The next time on the X-axis is 7.5. I might just fill in all my X-axis right now. 22.5 and 30. And then 7.5 is the halfway up. 15 minutes is at the top. 22.5 halfway down. And 30 minutes is all the way back down. And now we need to do a sinusoidal regression in our TI-85 calculator. There are instructions on your reference sheet, so refer to them. Make sure this makes sense to you. You're going to click Stat and 1. If you have to clear anything, you have to do clear, enter, but we don't have to do that, okay, because there isn't anything there. We type in our X information in the L1, 0, 7.5, 15, 22.5, 30. Our Y information in the L2, 0, 67.5, 135, 67.5 again. Oh, I typed it wrong, 67.5, and 0. There's something I'm missing. Oh, I have an extra number here. Delete. And then this is 67 point, no, it is 7.5. Oh, thank you for your patience. I'm going to get this, oh dear, clear. 67 point, clear, 7.5. All right, now after all of that, I'm just going to double check. Those are the numbers in my X column. Okay, and then these numbers are the correct numbers to have from my Y column. You go to your Stat button, you arrow over to Calc, you arrow all the way down to till you see Sine Regression, hit Enter, 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 and now you write down the function that you have. Now, here's a good reminder. I mentioned this in the first part of the tutorial. You do have to write it with the y equals notation, or that's a deduction, and round everything to to 2 decimal places. So times sine and then the b value. Okay, I'm just gonna say that we would put the b value in there with the x and the c value in there and finish this off. And we could go and then enter this equation for part B. You would enter this equation into Desmos. They've given you a height, and so you would decide, is the height a y value or an x value? This is a y value. You put in y equals 100, but you'd have to now do this in Desmos, okay? Because I didn't teach you how to do it in your graphing calculator. When I'll do that in just a second, and that'll end our tutorial. All right, so I finished writing my sine function from my TI-85 calculator, and then I typed my sine function into Desmos, and I made my graph settings 60 minutes because I thought that that would show me 2 full rotations, which might be kind of nice. And then let's read over the follow-up question that we have to do. How many minutes would a passenger be at least 100 meters above the ground during 1 complete rotation? So if we put in our height as y equals 100, we're going to click on the first 2 places, and we can see that they're going to start being 100 meters off the ground at 9.8 minutes, 9.87 minutes, and they'll go up to the very top, then they'll start coming down, and at 20.04 minutes they will reach 100 and start to be below the ground. So if you subtract those 2 numbers, okay, and you can subtract them as their exact numbers and then round at the very end, 20.044 subtract 9.868 equals 10.176 minutes. So our answer could be 10.18 minutes is the time that a person will be above 100 meters when they're riding this Ferris wheel. Okay, thanks for hanging in there with me. We got through these tips, and good luck tomorrow.